So for the generalized product rule, it is basically the number of possible outcomes of a given scenario where you are actively excluding one of the previous numbers that was selected. So an example would be this one right here, where you're at, let's say, Thanksgiving in this case. There are 10 different food choices, but your plate can only hold 4 of them. So that would be a case of where the generalized product rule would come in, and it would end up looking a little something like this for the number of possible combinations. Um, and this is because slowly but surely you're taking up a different slot of that fourth one, and you're counting down the number of possible choices of the food itself, assuming that, of course, you don't repeat. The inclusion exclusion principle is it basically looks at combination of sets subtracting the intersections of the sets. So, for an example, I have 10 women, 8 blondes, and 3 blonde women. What would end up happening is it would end up being a possibility of 15 because we subtract out the 3 because of the general overlap between these two. They're both blonde and they're both women. So we would end up subtracting those ones out because of the general overlap. Now, permutations versus combinations are really similar, but also very different. So they both are looking at the possibilities of certain stuff. However, the main difference is that combinations have absolutely no care whatsoever in terms of the order of appearance of the items versus permutations, in which it does matter the order of the items itself. And then for combinations, or for uses of combinations, I wrote down locks. For instance, if you have a dial lock, which has, let's say, n number of different discs in which you can rotate 0 through 9, it would end up being 10 to the n, where n is the number of possible discs, not possible discs, the number of discs in that lock. And then I was in my coding class, and one of the things that we were actually going over was cryptography and looking at the combinations from the possible cryptographic numbers and keys. Another one as well is whenever we're looking at cards, stuff like blackjack, poker. There's a number of uses in which combinations will come in very, very useful. And then one more concept to go over is multisets. Multisets are your standard set. However, in a set, there usually is no overlap of numbers. In this case, I have the word Mississippi up here, and there's a large overlap of numbers, as we can see here and here. And it would come out to this as the possible arrangements if you were wishing to scramble the word Mississippi. So the difference between multi-sets and generalized sets is that a multi-set can have multiple of the same value. So you can also have a set of 3, 3, 4, 2, 4, 3, and that would be a multi-set because it would have an overlap of numbers, but it would not be a proper set.